Welcome to aminacademy.com. In astronomy, let us discuss about atmosphere of the planets. Atmospheres of the planets were formed by combination of gas escaping from their interiors and the impact of volatile rich debris from the outer solar system. Each of the terrestrial planets must have originally had similar atmosphere, but Mercury was too small and too hot to retain its gas. Moon probably never had an atmosphere since the material composition it was depleted in volatile materials. The predominant volatile gas on the terrestrial planet is now carbon dioxide, CO2, but initially there were probably also hydrogen containing gases. In this more chemically reduced hydrogen dominated environment, there should have been a range amount of carbon monoxide and traces of ammonia and methane. Ultraviolet light from the sun split apart the molecules of reducing gases in the inner solar system. However, most of the light hydrogen atoms escaped, leaving behind the oxidized, that is, oxygen dominated atmosphere we see today on Earth, Venus, and Mars. The fate of water was different on each of these three planets depending on its size and distance from the sun. Early in its history, Mars apparently had a thick atmosphere with abundant liquid water, but it could not retain those conditions. The CO2 necessary for a substantial greenhouse effect was lost, the temperature dropped, and eventually the remaining water froze. On Venus, the reverse process took place with a runaway greenhouse effect leading to the permanent loss of water. Only Earth managed it to maintain a delicate balance that permits liquid water to persist on its surface. With the water gone, Venus and Mars each ended up with an atmosphere of about 96% carbon dioxide and a few percent nitrogen. On Earth, the presence first of water and then of life led to a very different kind of atmosphere. The CO2 was removed and deposited in a marine sediments. The proliferation of life forms that could photosynthesize eventually led to the release of more oxygen than natural chemical reactions can remove from the atmosphere. As a result, thanks to the life and thanks to God to the life on its surface, Earth finds itself with a great deficiency of CO2, with nitrogen as a most abundant gas and the only planetary atmosphere that contains free oxygen. In the outer solar system, Titan is the only moon with a substantial atmosphere. This object must have contained sufficient volatiles such as ammonia, methane, and nitrogen to form an atmosphere. Thus, today, Titan's atmosphere consists primarily of nitrogen compared with those on the inner planets. Temperature on Titan are too low for either carbon dioxide or water to be in vapor form with those two common volatile frozen solids. We see that nature, starting with one set of chemical constituents, can fashion a wide range of final atmospheres appropriate to the conditions and history of each world. So far, the reach of habitable environment has focused on the presence of liquid water. Earth and Europe, Earth and Europa both have large oceans, although Europa's ocean is covered with a thick crust of ice. Mars has a long history of liquid water on its surface, although the surface today is mostly dry and cold. Now we'll discuss further detail about atmosphere of the planets. The planetary atmosphere are layers of gas surrounding a planet held in place by gravity. Those atmospheres vary greatly in composition and density depending on the planet size, temperature, and formation of history. Key aspects of planetary atmosphere. Planetary atmosphere affects by the following things. First, composition. Planetary atmospheres are primarily composed of gases. The most common gas includes hydrogen, helium, nitrogen, oxygen, and carbon dioxide. The composition of planetary atmosphere varies greatly. Earth's atmosphere is primarily nitrogen and oxygen, while Venus and Mars have atmospheres dominated by carbon dioxide. The giant outer planets like Jupiter and Saturn primarily consist of hydrogen and helium. Earth's atmosphere has evolved over time, while the atmosphere of the giant planets are though thought to be closer to their original composition. What about the thickness of the atmosphere? The thickness of an atmosphere can range from extremely thin, like a Mercury's, to the incredibly thick, like Venus. Look at this figure for thickness of the atmosphere. The thick of a planet's atmosphere is not a fixed value and varies greatly between planets. It depends on factors like gravity, temperature, and the planet's composition. Some planets have very thin atmosphere, while other, like a gas giant, have extremely thick one. How it formed? Atmospheres can be primarily formed during planet formation or secondary, like formed later through the volcanic activity of or impacts. Planetary atmosphere formed through a combination of process, the accretion of gas from the protoplanetary disk, outgassing from volcanic activity, and the impact of icy bodies. The composition of and evolution of an atmosphere are influenced by factors like a planet's size, distance from its star, and the star's radiation and stellar wind. What is the importance of the atmosphere? Atmospheres play a crucial role in regulating temperature, protecting from radiation, and influencing weather patterns. Some example, Venus has thick atmosphere, primarily carbon dioxide. Earth, nitrogen and oxygen atmosphere, essential for life. Mars, thin atmosphere, mainly carbon dioxide. Jupiter, thick atmosphere, mostly hydrogen and helium. Titan, a moon of Saturn, with a thick atmosphere rich in its nitrogen. Extraterrestrial atmospheres, what is that? The atmosphere are also found around other celestial bodies like moons and even planets orbiting other stars. Extraterrestrial atmosphere vary greatly across the solar system and beyond, exhibiting diverse compositions, pressures, and temperatures. While some planets like Earth and Mars have a relatively thin atmosphere composed primarily of carbon dioxide, others like Jupiter and Saturn boast massive gaseous envelopes primarily composed of hydrogen and helium. Exoplanet atmospheres discovered through telescopes like a James Webb Space Telescope showcase an even wider range, with some containing water vapor, methane, and even clouds made of exotic material. Factors influencing atmospheric characteristics. Some factors we'll discuss. Planetary atmospheres form through a combination of processes, the accretion of gas from the protoplanetary disk, outgassing from volcanic activity, and the impact of icy bodies. The composition and evolution of atmosphere are influenced by factors like a planet's size, distance from its star, and the star's radiation and stellar wind. What are the factors? Then gravity. Stronger gravity helps a planet retain a thicker atmosphere. Temperature. Hotter planets tend to have a thinner atmosphere because gas molecules move faster and are more likely to escape. Volcanic activity. Outgassing from volcanic volcans can contribute to atmosphere's composition. Solar radiation. The sun's energy can strip away a planet's atmosphere, especially for planet closer to the star. Interaction with space. Atmospheres can interact with the solar wind and other space phenomena. So far, we discussed about atmosphere of the planets. We have done. Please subscribe our YouTube channel.